Hi, I'm Ellie Fields, and I'm here to talk to you about how we scaled our service up 10x in the COVID-19 situation. I'm the SVP of Product Development at Tableau, in charge of Tableau Public and several other services. I've been at Tableau for about 12 years, and my teams run the product and the engineering for Tableau Public, Tableau Mobile, and our browser-based services. And presenting with me today is Jared Scott, who is the Director of Software Engineering for Tableau Public, and you'll hear from him later in the presentation. And we're really excited to share with you this story of how we scaled up our service. So what are we going to talk through today? We're going to talk a little bit about the increased demand for data during the crisis, and that was what our service was serving, was data during the crisis. What is Tableau Public? The Tableau and the AWS response, and then what can you take from that for your own deployments? So let's jump right into it. So when the COVID-19 crisis hit, we saw a massive increase in the demand for data from all quarters. And what you see here on this slide is on the left a graph of the traffic coming into Tableau Public, which was about 1.5 to 2 million hits per day. And then what happened as COVID-19 hit. And the demand for data went way up. The number of views of data on this public data sharing service, Tableau Public, went way, way up. And what you can see on the right are examples of some of those visualizations. In fact, some of the earliest ones from sites in Europe, NTV, and sites in Italy and Spain were sharing data about what was happening with the number of infections in the COVID crisis. And what's interesting about the data that they were sharing is that it was really important to people that the data be local. Global trends were interesting, national trends were interesting, but in these moments, people really, really cared to know about what's happening near me, what's happening in my community. And Tableau Public's a great tool for being able to share hyperlocal data stories like that. And so we saw many hits from some of these visualizations and many viewers on those visualizations, which of course drove up traffic to our service, which was serving these interactive visualizations. So what we were trying to do, along with a lot of our customers, was actually keep the public informed about what was happening. And in this view, you see a California view about the data that was happening there at the time. And this is one of those hyperlocal views where people really wanted to see at the state level what was happening. Many Tableau customers are state and local governments. And they had been sharing some amount of data and were quickly overwhelmed with how much data that their constituencies were requiring from them. So typically government websites are pretty low traffic, and if you put a visualization of data up there, you may get a few thousand, maybe a few 100,000 hits a day, but nothing like what these governments were seeing right now. And so many of these customers reached out to us for help, and this was many states, a number of cities, places around the world, in fact, reached out and said, hey, can you help us serve our public with this really, really critical data? And for those of us in Tableau, of course, we always want to help our customers, and we were really moved to help them. But I think it was also a big moment for us where we wanted to help with the overall crisis as well. And we really felt a mission and a duty to help keep data available to people locally so they could understand what was happening in this critical moment. At Tableau, we believe that data is important to all kinds of public conversations. And this was one that really drove home the point that data and data that's specific and local to you is really critical to people's lives. It's critical to how they understand what's going on around them. And so we really saw this as a moment where we had to step up and support our customers and also support the public with this product in this run-up of data. Now let me talk for a little bit about why our customers were coming to us for help. As I said, many of these state and local governments, they use Tableau already, but they used it in an on-premise fashion. So in a lot of cases, they had an 8-core machine somewhere. They installed and ran the software on their own, and that had been completely sufficient for the challenges that they'd had before, the amount of traffic that they'd had before. But these deployments were not configured for the high load of views and inbound traffic that they were getting. In addition, these governments did not have 24/7 support on these sites. So if something happened, they didn't have people who were ready to get on it and move really quickly. we were running a global scalable public service, so of course we did have 24/7 support, and our deployments for Tableau Public were configured to meet high vis workload. So I've been talking about Tableau Public this whole time. Let me pause and give you a little bit more of a picture of what is Tableau Public. What is this service that we're talking about that we had to scale up so high? Well, Tableau Public's been around for about a decade, and it's a service that lets you create and publish interactive visualizations on any data set, working with Excel data or data in Google Sheets or other file-based systems. It's a version of our corporate software that has a fewer features and also requires that the data be public. So Tableau Public lets you publish any kind of data, but you shouldn't put secure data in there. You shouldn't put your HR data or your finance data in there. This is really for supporting public conversations around sports or the environment or justice or any topic that you have data on. But it is a sharing site. It is a site for public data. The traffic can be very high because we actually allow authors to not only create and share these visualizations, but embed them in other sites. So some of those earlier visualizations I showed you from NTV, for example, were embedded in news sites like the NTV site. And those sites have a lot of traffic. And so when a visualization gets embedded in a high traffic site, of course, it gets a lot of views to that visualization. And that's where a lot of our traffic was coming from. A few technical details. Tableau Public is actually very, very much the same as our corporate software under the hood. A lot of the same components, it does a lot of the same things, and even the secret sauce of Tableau is there. Some capabilities, like the ability to connect to production databases and refresh that data, have been turned off because it's a public use case, usually smaller data, usually file-based data. Tableau Public is configured for massive scale, and we have had many spikes to Tableau Public over the years. Typically, they've been, one spike that comes and fades, not as we saw in this time, multiple spikes that sat on top of each other and continued. But we were seeing about 30 million views a week after this crisis, and about 10 million a week before. We do host the service, and we have an on-call team all the time that's ready to deal with any issues that may come up. As I said, we've been running it for 10 years, so we've been learning how to deal with traffic spikes. And I've gotten pretty good at it, and so we had an idea of what to do as this crisis hit. One final note: Tableau Public's really interesting and important in the Tableau product world because it's a place for us to innovate and try new things out. So, for example, Tableau Public was our first service to go to AWS. It was our first service hosted on Linux, and it's actually been the first many times, whether it be on customer-facing features or infrastructure issues, to try and help us move forward and move the whole product platform forward. So why did this service become so important at this moment in time? Well, as I was talking about, these governments, they needed to move fast. They were getting all this interest in this data. People considered this local COVID data really critical. And the governments found that they weren't able to provide it. And so as they saw their on-premises deployments unable to scale, they really were left with a few options. One was try to just scale up on premises, add machines, scale out, scale up. That was going to be difficult for them to do. I mean, that's something that takes a few days or weeks. In the best of times, these governments at this time felt like they had hours or days to scale up. They could take that software and put it on the public cloud, which would help them scale and get more machines quickly. But what it wouldn't do was take the management burden off of these governments. So they would still have to install and manage the software just as you do when you install any software in the public cloud. And finally, their last option was to go with our hosted option for public data, which is Tableau Public. And many of them chose to do that for the reasons I described, the scalability that was already built in, the 24/7 support, the experience in dealing with this kind of a workload. And so we saw these customers moving into public very, very quickly and publishing additional visualizations on these government websites, which of course contributed to the traffic load because now there are more visualizations out there being served in the world. Now I'm going to take a pause and talk about our Tableau Public's sister product, Tableau Online, which is really for corporate use cases. So I mentioned that Tableau Public is about public data and public conversations. There's not data security there. we do have a Tableau Online product, which is also hosted and is secure and is for companies' private data. And we have many companies that use it with their most sensitive data, whether it be HR, financial, business data, and so on. Some of these customers during this time also wanted to use Tableau Online for the private sharing and the traditional analytics or business intelligence use case. And the reason why they wanted to do that was because many of these governments were responding to the crisis at the same time. So they were mobilizing their workforces around healthcare or around sanitation or even transportation and trying to figure out how they would respond. And they didn't want all of that data necessarily to be public. And so some of these organizations also went and used Tableau Online. As you might expect, because Tableau Online is not public facing, it doesn't see the same kind of high workload on viewing visualizations, but it does have a different kind of workload on refreshing data and some other profiles of the data workload. So this was our authenticated and secure solution, and we also took some customers into that. I want to give you an idea now of what some of these dashboards look like, and maybe you saw some of these at the time, but these are a selection of dashboards from different places: Connecticut, Colorado, Waterloo in Canada, where governments were taking the data that they had and trying to visualize that to make it understandable to people and share it out with the public. And these are just a few examples. We literally saw dozens and dozens from different governments, and then many more from news sites, and even private people were getting in there and looking at the data and trying to form hypotheses and draw conclusions. And we saw interesting evolutions of this data as well. One of the really key aspects of Tableau is that it lets you iterate quickly and bring in new data and shift your perspective very, very quickly. You don't need a developer to do that, and you don't need many days to build out a new dashboard. You can just do it right in the drag and drop experience. And so we saw governments, in this case King County in the state of Washington, really evolve how they told the story with data. This was the first dashboard that King County published, a fairly standard dashboard showing where cases were and the trend over time. In the ensuing months, King County went and did other things. They published economic, social, and health impacts and a number of dashboards that supported each of the indicators that you see here. They looked at the impact by race and ethnicity, another way to look at the same data. They looked at long-term care facilities and what was happening there. All of these created and published in Tableau Public and published onto the King County government website. And finally, King County looked at long-term indicators of what was happening with this data so people could understand when reopenings would happen and when we would get back to work and so on. So the ability to create these visualizations and publish them in a hosted way allowed governments like this to be able to refine and go deeper and deeper and deeper into the story and help people understand more and more about it. And with that, I want to turn over to my colleague, Jared, who's going to talk a little bit about the response and what you can learn from it.
Hi, everyone. Thank you, Ellie. I'm, as Ellie mentioned, I'm Jared Scott, Director of Engineering for Tableau Public. And I'm going to have the opportunity to talk you through the technical details as to what we did to identify bottlenecks and stabilize our system to handle that traffic increase. As a little aside, if I may, I just wanted to take a chance to share how special this last year has been from my perspective as somebody that went into technology to really want to use technology for social good and for making the world a better place. During my interview process with Tableau, one of the big sellers for me was a story that was shared about how data and technology was used to help reduce malaria in North Africa. And that kind of closed the deal in my mind. And so joining the Tableau Public team, I obviously hoped that there would be an opportunity for me to be part of something special like that. And going into this Tableau or this weird pandemic that we've been in, being a global incident that really impacts everybody from every part of the world, every race, every gender, and being able to use data to help people be safe and help people flatten the curve in their parts of the world. Being part of that was just really special. So thank you for letting me share this journey with you. Yeah, So now to the more technical, geeky stuff. As just sharing this graph that Ellie shared earlier as an opportunity to just kind of show normal and not normal traffic. On the left, you'll see we weren't really flat. We were kind of gradually increasing. It's hard to see in this graph, but week to week it was relatively flat, and then we would have an event, whether that was a sporting event or some kind of political event that was very localized to some part of the world. In Germany, a soccer game, for example, or in Argentina, a big political event that would draw traffic, that would be localized, short-lived, and then it would kind of go back to normal. And as you can see on the right, we have this big mountaintop that's sustained. We all of a sudden had people from around the world, all different time zones, hitting us at the same time. The peak traffic in each area really leaving us in a state of redlining, all day, every day, for an extended period of time. And so we had optimized ourselves for these little peaks that we saw. We had not really anticipated or been able to optimize for this massive sustained spike. And it taught us a lot of things about our architecture and our design that hopefully we can share with you and help you learn and apply to your systems. Before I jump into the details, just a quick timeline overview of, when we really started getting hit hard was those visualizations that Ellie showed of Europe. When things started to show up in Europe, we started to see some of our partners getting hit with much, much higher traffic than what we'd seen in the past. I think one visualization at one point hit 17 million views in a day just for one visualization. And so these partners were contacting us and asking us to help, optimize and stabilize the system to be able to load these visualizations quickly and serve their customers. As Ellie mentioned, often those are embedded in third-party sites, so we wanted to be able to have snappy experiences and get that information to people quickly. We were all hands on deck. We had all kinds of different teams from throughout Tableau helping out with this. And towards the end of March, we started to engage with our partners in AWS to figure out also on the physical kind of architecture side, in AWS, what could we do to optimize? Are we set up for success there? And how can they partner with us to help offset some of the costs that we were seeing in this and to make sure we're optimized? So in that normal traffic time on the left of that previous visualization, we typically saw that spiky traffic was often small data sets, localized, as I mentioned, short-lived, and the interactions taken were usually minimal. People would see the visualization in some news article. It would, of course, be of interest to them, but it was, did they win the soccer game or did they not win the soccer game, kind of move on. What we saw going into COVID was the sustained traffic with very large data sets at a global level and many people wanting to see the thing that matters to them. Like Ellie said, people wanted to know, in their city, what was happening. So we saw an increase in the number of interactions people were taking. And another big difference, which we didn't really, I suppose, anticipate, was the types of people that were generating very popular visualizations were not versed in optimizing our visualizations for quick, responsive interactions. And so those were behind the scenes, those generate queries to our databases and stuff. And so we saw a pretty big load on our databases and on our systems to be able to kind of keep up with the types of visualizations that were being generated. So I'm just going to give you an overview of our architecture, and then I'll kind of deep dive into where we found the bottlenecks and what things we needed to do to make improvements there. So most of our system is in AWS. We have one small part, the CMS that sits outside. I'll just mostly spend time on the right-hand side here. So AWS Shield protects our CloudFront, which goes through an ELB, and then gets into the parts of the system that I'm assuming you'll find interesting. So on the left is our social platform. That is the part of Tableau Public that allows us to do things like follow other authors, favorite visualizations, share to social media, Twitter, LinkedIn, whatever it might be, all those types of things. And we've modernized a lot of that to run on Kubernetes. So we're running an EKS and moving towards things like auto scaling and a lot of the interesting kind of cutting edge ways to do things. On the right, what Ellie was referring to is that we share a lot of the same guts as the Tableau server system is essentially a Tableau server or Tableau online instance that is running a bunch of Tableau servers to render the visualizations. And those are, for those of you who want to kind of know some of the details on the tech, we're going through an F5 load balancer. And then we have EC2 instances that are M4 4XL. We had 50 of them. This is pre-pandemic, so pre-COVID spikes, running to a Postgres Aurora database. And what we were seeing was either visualizations were rendering very slowly, or worse, servers were crashing and visualizations weren't rendering at all. So we were, going through the system, tracing requests and trying to figure out what part of the system needed to be scaled and how. So we quickly identified that the area that wasn't keeping up was, the engine of the system, which is the part that generates and renders those visualizations in our Tableau server part of the landscape. Pretty obvious thing, if your pipes aren't thick enough, you're not going to get enough traffic through them. So we found out that our ELB was configured for 1 gigabyte per second, which was plenty in normal times and even with those minor spikes. But once you got into the sustained 10x traffic, there's no way that it could keep up. And so I guess from a planning ahead perspective, if you anticipate large amounts of traffic, make sure some of those pipes that are routing traffic through your system are set up for those for the increased load. Slightly more interesting is getting into the Tableau worker machines. So those are the individual servers that are rendering the visualizations. In there, we have some Java services that are running some business logic and some C++ services that are doing the heavy lifting of the rendering, and a proprietary database that does a bunch of preloading and caching of data. And then to the right, of course, our Postgres database. So as we were looking at why are these servers restarting and crashing and slow, we started with the really obvious stuff on the outside edges. We saw our JVM heap size was not big enough. We went from 2 gigabytes to 8 gigabytes per server. We saw that the machines just didn't have the compute and memory that we needed to be able to handle that much load hitting it on a sustained basis. So we went for beefier machines. We actually went up to R5 8XL for those of you who are interested in what type of machines would be able to handle that load. And we horizontally scaled as well to add up to 200 at peak. We're back down to 100 now, and we're able to sustain the traffic. Even recently with the U.S. elections, we've been able to sustain that type of traffic. So those things are probably, for most people, fairly obvious things that you could optimize. Some of the less obvious things were once we got into the code, we were starting to see things like, we'd optimized for preloading certain things for the data analyst experience. The type of user that Ellie was describing, government agencies or in the corporate environment, your business analyst type would want to be able to preload a bunch of things so that when they're interacting with the visualization, it would be really snappy. But there's a cost of that. That basically means at the beginning we're doing all this loading that may not be necessary. So what we found is we were able to defer some of the execution of the code only to when the user actually asked for it. So kind of making sure, and we did that config based. So basically, depending on how you've deployed your system, whether it's for more of an on-premise business analysis type of environment or a Tableau Public like consumer environment, through configuration, we can optimize for preloading or not preloading. So making sure that you have a way through config to optimize for your deployment environment. The second thing was in the APIs themselves, calling unnecessary functions. So having too many things that you're trying to do that maybe are not necessary for just rendering a visualization. things that maybe got added over time for a UI experience in the corporate product. And we needed to kind of start to break some of these monolithic APIs up. And then lastly, and a very important one, is the circuit breaker pattern. So, with all of these optimizations and increased compute, what happens if even then the machine can't keep up? And so adding a way to provide a good user experience, even if the system is not behaving, can create a good user experience for your users, and for our users in this case, to feel like they're getting the experience even though there's something behind the scenes that's not going well. So we actually were able to generate a static image which you could click into to interact with the visualization, which would defer the compute of having to render a viz until a user actually said that they want to do that. So in the cases where it was embedded in a news site and they just happened to scroll past the visualization, they would just see the static image and there'd be no compute costs for us. So that almost allows us to scale infinitely, given in the consumer environment, the number of interactions with the visualization is actually fairly low. Okay, and then lastly, obviously, many times in large systems, the database becomes the bottleneck. So being able to either defer, not use the database, cache, and then of course, get the right size instance. And in this case, we needed to increase the instance size of our database. So before I wrap up, I just wanted to talk a little bit about the partnership with AWS. AWS provides an opportunity to bring an architect in to review your system, make sure that it's secure, reliable, cost optimized, that you're using the right types of services. And if you have a special event that's coming up, they're able to kind of help you plan for that event, help you plan and prepare for the increased load that you might experience, and make sure that you're set up for a successful event. Obviously, in this case, we didn't have that heads up. It came quick, and our partnership with AWS, kind of end to end, was less than 2 weeks. We were able to get this done from the typical 4 to 6 weeks. So thank you to our partners at AWS. Cloud design principles that we went through that process were using infrastructure as code. So being able to deploy services and manage services without having to have a human go and manually do that. The right service for the right purpose, both the AWS service and, are you using Node or a Java service or C++ service, making sure that you're using the right type of service. Security from the beginning, designing for failure, decoupling your components, and I'd say also decoupling your code and your API layer, elasticity, and automation. And so the big ones that we applied through this process were, obviously, we needed to horizontally and vertically scale, and we were able to do that pretty quickly because we had done this infrastructure as code approach. Designing for failure, so that circuit breaker pattern that I just mentioned, one of the most common places I've seen this circuit breaker pattern being useful is, on a login flow, maybe trying to do too much logic there, or if one of those things isn't working, do you still give a good experience for your user? Decoupling your components, and as I mentioned, we had things going on in our API that were not necessary for the particular experience we were trying to show. So finding places in your business logic that is doing too much, and then elasticity. So being able to scale both your services and your database horizontally, vertically, and potentially deferring processing to make sure that you're getting the most out of your compute. So before I close here, just if you are a person that has a Tableau deployment or is considering a Tableau deployment, applying these learnings is pretty critical. We have the ability to deploy on-premise or a private cloud if you want to deploy to AWS yourself. And of course, we have our hosted services and then Tableau Public. And the things to consider is, do you have an event like COVID, or elections or a census or some kind of big event that's going to draw massive amounts of traffic? And what happens if that traffic goes to 20x, 10x the amount that you're used to? Are you prepared with 24/7 support? Do you know how to scale? Are you optimized for caching and all the different things that I just talked you through? And obviously, getting the right type of deployment for the right type of event, or for that kind of worst case scenario, will set you up for success through that. We're going to attach a bunch of resources to this slide deck. So if you want to download it, the COVID-19 Data Hub gives you all kinds of cool visualizations from around the world if you want to look at that. We have a tool called work.com from Salesforce that allows you to safely reintegrate into the office. And then there's some resources on your AWS deployment using Tableau and some of the best practices for setting up a SaaS system like this. And with that, just thank you very much, and I appreciate the opportunity to share with you.